What's up, guys? This is Phillip with the Desmos Visionary. I'm back with a super cool function to show you guys. I made this pretty neat graph in Desmos, and what it basically does is show you the arc length of pretty much any function you want. So there's some pretty complicated calculus involved in this. The arc length formula is pretty complicated, but all we really need to know is that the length from this point to this point is this value right here. So what we can do, I'm going to prove that this works to you guys. I can move this point around, and because my function is 0 right now, the distance will just be whatever value this value is right here. But if I was to make this graph like x, then this value times the square root of 2, or about 1.4, is what this value is going to be, because that's the length of this line right here. But as you can see, can't type today. As you can see, this value right here matches up with this, which means, at least for a horizontal line, that this works. So what we can do with this is we can look at some pretty neat functions. And see some pretty exciting stuff. And another neat thing we can look at is maybe compare some distances. So if I were to set this value at 2 pi, then the distance right here is 7.6. And that's for the sine curve. But what I want to know is, if I take one period of the sine curve's length and one period of the cosine curve's length, is it the same? And we can test that with this graph. If we do that, still going to 2 pi, it's still 7.6. And that's because cosine and sine are pretty much the same curve, just shifted over a little bit. So if you take one full period, you'll have the exact same distance between the two graphs. You can use this graph to test other really neat, cool math things that you want to look at. And I encourage you to go do that. I'm going to post this Desmos graph in the description, and you can go and play with it yourself. Well, guys, thanks for watching. This is Phillip with the Desmos Visionary.